So this is going to be 8.4. We're going to talk about angles of depression and elevation. So we're going to use some of the stuff that we learned in 8.3 to solve these, but these are going to be the real life examples of them. Okay, so angle of elevation, or angles of elevation and depression, are always formed with horizontal lines. Okay, so these always are formed with horizontal lines. So there's always going to be a horizontal line in there. Okay, angle of elevation. Suppose you were looking up in an airplane. The angle formed by a horizontal line. So here's a horizontal line. And your line of sight to the airplane is called the angle of elevation. So your eye line elevates. Okay, so when you're looking up, it's the angle of elevation. Angle of depression is when you have your horizontal line and your line of eyesight goes down. So if you can think about it, if someone gets depressed, sometimes they look downward. Okay, so the angle of depression is when something is looking down. Your line of sight goes down. So suppose you're standing on a cliff and looking down at a river below. The line stretches horizontally from your point of view on the cliff. Your angle of sight to the river below forms an angle of depression with the horizontal line. You can use your knowledge of trigonometric ratios to determine the distance and lengths using angles of elevation and depression, which we're going to talk about in a little bit. So example 1, suppose you're a lifeguard looking down at a swimmer in a swimming pool. Your line of sight forms a 55-degree angle with a horizontal line. You are 10 feet in your seat, 10 feet up in your seat. How far is the swimmer from the base of the lifeguard stand? Okay, so this is going to be an angle of depression because their horizontal line, they're looking downward at the swimmer. So we're going to use our trigonometric ratios that we learned about last class to figure this out. So first off, I'm going to name my triangle. This is my hypotenuse. This is my adjacent angle because we're coming from angle 55 here. And then this is going to be my opposite. So I need to pick the ones that have these in it to be able to solve my problem. So if we go back to SOHCAHTOA, okay, so the angle that we're going to represent is 55, and I need something that includes my opposite side and my adjacent side, so we're going to use tangent. So I'm going to do tangent of 55 degrees is equal to my opposite side, so 10, over my adjacent side, so x. So let's get x by itself, so we're going to first multiply both sides by x. So we'll have x tan of 55 degrees is equal to 10, divided by tan of 55, divided by tan of 55. Okay, so x is going to equal 10 divided by tangent of 55 degrees. Okay, so to plug this in your calculator, you're going to type in 10 divided by tangent in 55 degrees, but you have to make sure you're in degree mode, because if you're not in degree mode, you're not going to get the right answer. So when you plug this in, you should get x equal 7 feet. And make sure you label on these. Example 2, a 100-foot tall building is casting an 80-foot shadow. So I have this building, and it is 100 feet tall, and it is casting a shadow of 80 feet. What is the angle of elevation of the sun at that moment? So elevation means it's something that is kind of looking upward. So here's my sun, and I want to know what this angle is here. Okay, so I need something, well, let's go ahead and label our triangle first. So we have a hypotenuse, we have the side that's opposite to that angle, and we have the side that is adjacent to that angle. But we don't know what that angle is, but I need to include the 180 in my equation. So we need something that has to do with opposite and adjacent. So we don't know what the angle is, but we know we're going to use tangent because that has to do with the opposite side and the adjacent side. So we're going to do tan of x, because we don't know what that angle is, equals my opposite, so my 100 over 80. To get the x completely by itself, we got to get rid of this tangent. So we're going to use the inverse tan button. So if we do the inverse tan of both sides, so it's going to look like that on your calculator. You're going to do tan of that -1 of 100 over 80. So that will equal my x. So x, once I plug that into my calculator, will equal 51.3 degrees. So that degree measure here is 51.3 degrees. Suppose you're looking at the top of a building. The angle of elevation from your eyes to the top of the building is 65 degrees. So here's my building. Here is my, here, let's show this. Let's draw my person first. Here's my person. Okay, so suppose you're looking at the top of a building. So we're looking at the top of this building here. The angle of elevation from your eyes to the top of the building is 65 degrees. You're standing 80 feet from the building, so we know that this is 80 feet. And your eyes are from the building, and your eyes are 5 feet above the ground. So we know that this is 5 feet. And we know this is 65 degrees. Because my angle of elevation, we have to have a horizontal line, and they're looking up 65 degrees to the top of this building. Okay, so this is still 85. So let's try to find at least this portion of the building first. So let's label our sides. So this is going to be my hypotenuse, opposite, adjacent. So I need to include my opposite and my adjacent side again. So we're going to do tan of 65 is equal to my opposite side over my adjacent side. Multiply both sides by 85. So 85 tan of 65 degrees is equal to x. So once I plug that into my calculator, I should get x equal 171.6 feet. But their eyesight is 5 feet above the ground, so we have to have 5 feet on top of that because their eyesight starts at 5 feet. So we add 5 to this, and my total height of my building now is 176.6 feet. Okay. Draw a diagram of each situation, labeling what you know and what you're trying to find. Solve the problem. Missy stands at a horizontal distance of 45 feet from the base of a building. The angle of the elevation from Missy to the top of the building is 48 degrees. What is the height of the building to the nearest foot? So we want to know the height of this building, if that's the top of the building. So let's label our sides. We have the hypotenuse. We're looking at this angle here. So this is my opposite side. This is my adjacent side. So it looks like we're going to use tangent because we need to include our opposite and our adjacent. So we have tan of 48 degrees equals my opposite side, x, over my adjacent side, 45. Get x by itself, so we're going to multiply both sides by 45. So now we have this, and then if we put it into our calculators, x is going to equal 50 feet. So D. Okay, the flagpole in Terry's schoolyard, so here's our flagpole, is 42 feet tall. On a sunny day, the flagpole casts a shadow of 20 feet. What is the angle of elevation from the sun? So again, it has to elevate. So it would be like the sun is looking at the top of that flagpole. And we want to know what that angle measure is. Round to the nearest tenth of a degree. Okay, so let's label our triangle. We have our hypotenuse. We have our opposite side, and we have our adjacent side. So it looks like we're using tangent because we need our opposite and adjacent again. So tangent of x is equal to my opposite, 42, over my adjacent, 20. To get rid of that tan, to get x by itself, we do that inverse tan to both sides. So x will equal that inverse tan of 42 over 20. So when we plug that into our calculator, x should equal 64.5 degrees. So A. Okay, Kurt leans a 20-foot long ladder against the side of his house. So here's the house. Here's my ladder. It is 20 feet long. The ladder reaches to a height of 18.9 feet up on the side of the house. So this is 18.9 feet because it hits the house where it's 18.9 feet tall. What is the angle of elevation of the ladder to the nearest tenth of a degree? So we want this angle of elevation here because this is my right angle and we have to be looking up. So let's go ahead, we're going to label this x. Let's label our triangle. So this is my hypotenuse, this is my side opposite of that angle, and this is my side adjacent to that angle. So we need the side that's the side, if we do SOHCAHTOA, we need the one that has the hypotenuse and the opposite side this time. So we're going to use sine. So we're going to use sine of x is equal to that 18.9 because it's my opposite side over my hypotenuse. So this time we're going to do the inverse of sine to get rid of it. So x will equal the inverse of sine of 18.9 divided by 20. So when you plug all that into your calculator, you should get x to equal 70.9 degrees. So C. Okay, you sight the top of a 50-foot tree from a point on the ground 50 feet from the base. So here's my tree. Should be 50 feet tall. You are 50 feet away from the base. Person. Boop, boop. Okay, what is your angle of elevation looking at the top of that tree? So remember, elevation, you're looking up, and we're looking towards the top of that tree. Okay, so let's say this is X. Label our sides, hypotenuse, side opposite to it, side adjacent to it. So we're going to use tangent again. So tangent of X is equal to my side that is opposite to it over my adjacent side. To get rid of tan, to get X by itself, we're going to do the inverse tan. So X is equal to the inverse of tangent. 50 divided by 50 is 1, so inverse tangent of 1. So when we plug all that in, we get 45 degrees. So B.